All right, so classwork 10.11, analyzing exponential graphs. So today we are going to do the first side of the sheet. So question number 1. Since it's a short day, that's all we'll do today. And then tomorrow we're going to finish it up. So then tomorrow we will do the back side, which is question number 2. Feel free to try the homework tonight if you want to. But if you want to wait and do the homework on Thursday night, that is definitely your choice. All right, so classwork 10.11. In 10.9, we analyze quadratic equations in y equals bx form. Today, we're going to expand our analysis to exponential equations in y equals a times b to the x form. Number 1, use your graphing calculator to complete the table for this equations. Then make a sketch of the graph on the coordinate plane provided. All right, so we've got our calculator. First thing I'm going to do with this is I'm going to reset it back to our normal place to start. So second plus 712. And then you can press enter. Once again, I recommend you do it. That way I can guarantee that your computer screen or your calculator screen will look the same as my calculator. All right, so y equals, I'm going to hit y equals, and then I'm going to type in 2 to the x. Press enter. And y2 is going to be 3 parenthesis 2 end parenthesis exponent button and then x. Technical difficulties. There you go. All right, so your calculator should look like the same as mine. It should also look exactly like the equations you see on your sheet. So we've got to come up with the table. So once again, we get to the table by pressing second graph. And that gives us our table. We have to scroll up a little bit so we can get -3. But once we're there, we can see the values. So go ahead and copy these down on your graph. Pause the video if you need to. All right, so those values should be on your table now in your paper. Once again, if you need to pause the video, go ahead. And then we're going to start graphing these. So you can hit on your calculator the graph button, and it will give you a graph, but you can also just plot the points. So go ahead and do that on your own. Pause the video, and then when you're done, go ahead and resume it. All right, so once again, there are 2 graphs. I did my y1 in the blue, and then y2 in purple. So you should get 2 very similar graphs with just a little bit of difference, and these should look exactly like what you have on the calculator. And you can see that my calculator does match my graphs pretty well. Okay, so let's then go and start working with the questions. Compare the 2 equations. What are the similarities and what are the differences? So similarities. Go ahead and brainstorm some of these. See if you can come up with any of these. Go ahead and pause the video, write them down, and then when you're done, come back, resume, and see if we match up. All right, so this is what I put. You may have more, you may have less. So for similarities, we've got a similar asymptote. Both of these graphs are increasing, and they're also both exponential. For differences, I've got the y-intercept is different, and the rate of increase is different. So the purple equation is getting faster a lot quicker. All right, B, compare the y values in the table for the 2 exponential graphs. What do you notice about the values for y2 compared to the values of y1? If you're looking at the decimals, that might be a little bit tougher. If you look at these numbers, do you notice anything between 8 and 24, 4 and 12, 2 and 6, and 1 and 3? And you should see that y2 is 3 times more than y1. So 1 times 3 is 3, 2 times 3 is 6, 4 times 3 is 12, and 8 times 3 is 24. So compare the graphs of the two equations. What do you notice? All right, so for when we compare the graphs, we notice that y2 is getting bigger quicker, so it's getting higher at a faster rate. Write the coordinates of the y-intercept and the equation of the asymptote for both equations. So looking at y1 first, my y-intercept for this blue equation is going to be right there. So that's going to be 0, 1. My asymptote for y1 is, remember, where do my values get closer and closer to, but they're never going to touch or hit it, and that's my x-axis here. So this y1 is going to get closer and closer and closer to it, but it's not actually ever going to hit it. So it'll be y equals 0 is my asymptote. All right, for the y2 equation, go ahead and do this one on your own, and then put that answer into Socrative. So I'm looking, first of all, for the y-intercept. Make sure it is in this type of form. So parenthesis, number, comma, number, parenthesis. No spaces or anything. And then for asymptote, make sure you put in an equation. So it should, once again, look something like this that I did for y1. So it should be y equals, and then the number of the asymptote. So go ahead and do those two into Socrative, and then we'll continue with question E. Go ahead and pause the video if you need to. All right, in question E, without graphing, predict what the graph y3 equals 4 times 2 to the x will look like. Check the prediction by graphing the equation on the graphing calculator. So go ahead and make that prediction. I do want these predictions on Socrative, so it's two different questions. Once again, you're going to give me the y-intercept. Give it to me just in the same form that you did the last one. And then also asymptote, once again, the same form. So give me it as an equation. And give it a shot. Try it without the graphing calculator, but if you do need to plug it into your graphing calculator and check it, that's totally okay. When you're done with this, if you want to give it a shot and go ahead and flip to the back and try and do that one on your own, go ahead. But there will be videos up tomorrow to watch if you get stuck. Otherwise, you can also try your homework.